Lecture 10 Pressure Conduct. When we conduct is mean can be different shape of the, for example, can be the rectangle or circle in general form of the pipe. But normally pipe we use to explain the circle shape on the pipe. And the pipe is a subset of the conduct. Okay. And what are the pressure conduct? The advantage is with closed conduct and flowing full, and it can avoid loss of water by seepage and by operation, and reduce the opportunity of the pollution. It's preferable for public water supply. Okay. That is the advantage of the pressure conduct. The basic equation to explain the pressure conduct, we use the Bernoulli equation or energy equation between section A and B. This figure shows the water flow in the pipe, and this is a pump. Okay, and the pipe in the inclined direction, and we can write equation of the energy equation. On the right hand side is the pipe flow in the horizontal plane, so we can write energy equation ZA plus the elevation head, pressure head, velocity head at point A is equal to ZB elevation head plus pressure head plus and plus the loss. Okay, so this is the equation, and if in this case if we it's a horizontal pipe line, so the ZA and ZB are equal, so we can cancel. And for the above, it's more complicated because it can be adding a H pump. H pump can energy equation like this. Okay, so hydraulic gate line increased, pump can increase the hydraulic gate line. Okay. And we can come to this figure, and to explain the head loss for the pipe friction, we use the Darcy-Weisbach equation. You have learned from the hydraulics, or already learned from hydraulics. It's Darcy-Weisbach equation. Head loss is a function of the length, diameter, and the friction factor. Friction factor is a function of relative roughness and Reynolds number. Relative roughness equal to E roughness height divided by diameter. So this is roughness height E, and this is diameter. Expand from the pipe is the length of the roughness in the pipe wall, and E we call the absolute roughness of the interior surface. And we use the Moody diagram for estimate the friction factor given the relative roughness and Reynolds number. And remind about the Reynolds number is equal to velocity times diameter times divided by mu. Mu is kinematic viscosity. Okay. The other equation that can use for estimate head loss we call Hazen-Williams formula. The head loss is function of R and Q and diameter. R is a function of the C. Okay, C is represent the type of the pipe. If it's extremely smooth, C is about 140, and C is old pipe and very large, rough and bad condition is about 60 to 80. And this is the equation between relationship between friction factor F and resistance R is a resistance coefficient from Hazen-Williams formula. How to use the Hazen-Williams formula is shown below figure. Okay. Given if we know the Q is 200 gallon per minute and design pi is 8 inch, so we can draw the line. Okay. From the Q is 208 inch. Like this. So we found that the loss, this is loss, and this is the velocity. We can loss is equal to, from the intersection to the loss of the head is about 1 feet per 1 feet of loss per 1,000 feet length, and velocity is equal to about 2 foot per second. Okay, that is how we can use we call the model graph. This is model graph for solving Hazen-Williams formula. Okay.